Good evening, one and all present here. We are here for the seventh week of live interaction session for the course for the NPTEL course on environmental impact assessment. The course instructor is Dr. Harshit Lapra. She is an assistant professor at the Department of Architecture and Planning at IIT Roorkee. We have two of these interaction sessions. One is by Miss Isha. These sessions happen on Saturdays from 4 p.m. to 6 p.m. usually. She is a PMRF and research scholar at the Department of Architecture and Planning, IIT Roorkee. The second session for the week is on Tuesdays from 6 p.m. to 8 p.m. It's handled by me. I'm Monica S. I am a PMRF and research scholar at the Department of Architecture and Regional Planning at IIT Kharagpur. So this is a sort of joint initiative between NPTEL and PMRF. PMRF is Prime Minister's Research Fellowship. So this is a merit-based fellowship given to research scholars across the country. And in order for us to, yeah, so we have a requirement to complete uh, some teaching in local colleges. And this scheme, this particular tie-up between PMRF and NPTEL is to enable us to sort of uh, get the hang of teaching as well as mm, to make these live interaction sessions useful for everyone. All right. So we have two major forums for interaction during this any of the NPTEL courses for that matter. So in this course, we have the weekly live sessions. This one runs every Tuesday from 6 p.m. to 8 p.m. So during the session, I would request you to raise your hand. Raise hand is an option in Google Meet, right? So you can raise your hand. And as I prompt you, like when I request you to, you can unmute and raise your query. Otherwise, questions can also be posted in the chat box. So the other main stream of interaction we have is the discussion forum for the course. And any questions related to the live session can also be raised there. The questions will either be addressed in the forum itself or in the next week's live session. Right? So a brief outline of the live session. We'll first have a very short recap of what was taught in week 7. Then we'll be looking at the assignment questions from the previous runs of the course. We'll be discussing answers and looking at a few explanations for each of these answers. Uh, for After that, we'll be continuing towards uh, the current week's assignment questions. So we'll sort of have again discussions of the answers and possible explanations. Towards the end, we'll have some additional content this week. So in between, there will be a 5-minute break somewhere around 7 p.m. And usually there is a bit of interaction going on. So when I prompt a question, I usually ask people to respond in the chat box as to what their response is, what they think the answer is. I the usual idea is not just to, it's definitely not to test the students, it's more to sort of enable some recall and an attempt at problem solving so that in the exam when you face similar questions you sort of know how to handle them. Like it's like an exposure to what might come in the examinations, right? So going for a short recap of the week's course contents. So week 7 was all about uh, environmental impact assessment methods. So the first two lectures of the week focused on air assessment. Then lecture 33 was on water assessment. Then we saw a few topics under soil, land, and geology assessment. And lecture 35 focused on climate and climate change. This was part one of climate and climate change, right? So in lecture 31, we saw definitions and concepts. We saw a list of air pollutants and in relation to human health. air pollutants in the natural built environment, odors, uh, scoping, baseline studies. We saw pollution data availability, on-site pollution monitoring, projecting the baseline forward. In the second part of air assessment, which was lecture 32, we saw physical models and expert opinions, numerical dispersion models and overview, principles of air pollution dispersion modeling, road traffic air pollution modeling, modeling inputs as in data requirements, model outputs, model limitations, odor effects, assessing significance, and some case studies. Lecture 33 was on the EIA methods pertaining to water assessment. So we had definitions and concepts, water quantity and quality, methods for scoping, method for baseline assessment, impact prediction and evaluation. I think it's impact prediction. Sorry. Impact prediction and evaluation of impact significance. Lecture 34, we saw the EIA methods pertaining to soil, land, and geology assessment. We saw a few definitions and concepts, methods in scoping stage such as desk study, field survey, laboratory work, methods of impact prediction, uh, basically impact on land and soil, then temporary and permanent land. Lecture 35 focused on EIA methods pertaining to climate and climate change, which is part one of a set of lectures. So we saw introductions, definitions, and concepts, and key legislations, guidance, and standards pertaining to uh, climate change within the domain of EIA. The issue with climate change is that it's difficult to sort of mainstream because it's a lot of variables and too much interaction going on. Right? So that's a recap. So since as of now none of the students have joined the lectures, so what I'll do is I'll start prompting the question, wait for a few seconds. I would request anybody who's viewing the video much later on YouTube to sort of figure out, or even if you think the time is going to be insufficient, pause the video, take a moment, recall what the answer could be. If you are not able to recall, I would even recommend going back to the lectures and checking what the answer is. Although I will be providing the answer later, but it's a good practice to sort of, go back to the materials and see where the answer is coming from. So that it's, helps in retention of the course materials. So moving on to the previous run week 7 assignment questions. Question number 1. Match the following terms of group A with their description of group B. So group A has two terms. One is P is air pollutants critical level and Q is air pollutants critical load. So the difference is critical level and critical load. Right? Group B has two different descriptions and you need to match. All right, let's see what the answer is. So Group E, the first term is concentrations of pollutants in the atmosphere above which direct adverse effects on receptors, such as human beings, plants, ecosystems, or materials, may occur according to present knowledge. So here we are talking about concentrations of pollutants in the atmosphere, right? And the second option we have in Group B is quantitative estimate of exposure to one or more pollutants, below which significant harmful effects on specified sensitive elements of the environment do not occur according to present knowledge. So this talks about, okay, so say there is a site, all right, and this is the atmosphere, right? So there must be some concentration of this pollutant in the atmosphere, right? So we estimate this, right? So this is the concentration. Whereas The second part talks about exposure to, right? Say there is a human being or there's some sort of settlement, right? Something, anything. So this units exposure to this pollutant. So this is a pollutant, right? So their exposure to this pollutant is the second aspect. So these are the key terms. One is a concentration, the other is an exposure. So this exposure, there is a certain exposure beyond which it starts affecting. Even for example, human beings, on a day-to-day basis, even like forget pollutants for a moment. Let's consider what is going on in the atmosphere. There is there are several organisms, there are several fungi that are sort of present in the atmosphere, but we don't really directly get affected by it. Yes, there is one aspect of immunity, but in general, on an average, for an entire settlement, there is a threshold beyond which that exposure becomes problematic, right? So below that level, significant harmful effects on specified sensitive elements of the environment do not occur. So below this level, uh, there is no reaction to the presence of this, or rather, no, there is no adverse reaction, right? So whenever we talk about concentration, that is our level. All right. If you look at the slides also, that's what we ma'am has spoken about, right? So this is taken from UNEC 1996. So it's the concentrations of pollutants in the atmosphere that will be called a critical level. So concentration is the critical level, whereas exposure is your critical load. I hope I'm being clear. Like as was given in the slides, you can see this is the quantitative estimate of exposure, right? That will be your critical load. So the answer is A. Right. Let's take a sort of uh, slightly deeper look at this concept, right? So this one talks about ammonia concentrations in the atmosphere. So you can see that it talks about critical levels, right? So we're talking about one cycle where it's ammonia NH3, then there's nitrogen and acidity, right? So this is a study from the UK. The link is given here in case you're curious. It's not a directly related study, but I thought it was representative to just explain the concept, right? So we're talking about ammonia concentrations, and then this talks about the deposition, right? Deposition is exposure. So ammonia is what is there in the atmosphere. So here nitrogen deposition to moorland, nitrogen deposition to woodland, acid sulfur plus nitrogen deposition. So these deposition aspects sort of contribute towards critical load. All right. One thing to note is that these critical levels are actually a particular point, right? Like, so you can keep monitoring the ammonia levels, say in the atmosphere. At a certain point of time, this critical level might be exceeded, or like for stretches of time. Our critical load is it's fundamentally a prolonged concept. So you keep getting exposed to a certain level. At a particular point, it becomes critical, right? So this say this is the exposure curve, right? After this, say human beings start falling sick, so that will be our critical load. So yeah, I hope that's clear, right? Moving on to the next question. Select the following atmospheric pollutants. Select the following atmospheric pollutants considered for the National Ambient Air Quality Standards NAAQS set by the CPCB, which are also considered for EIA. So we have four options: A, sulfur dioxide; B, oxides of nitrogen; C, particulate matter, PM10, PM2.5; D, all of the above. Uh, Looking at the answer, so this is the slide that deals with NAQS. You can see the list of pollutants, right? So you can see all of these: sulfur dioxide, nitrogen dioxide, or oxides of nitrogen, particulate matter, PM10, PM2.5. In fact, the standards uh, for ambient air quality are set by the Central Pollution Control Board, CPCB, right? So the answer is all of the above. Taking a slightly closer look at NAQS. So India's standards are basically NAQS, right? That's our air quality standard, what we have set as the upper limit for pollutants, say. And these are the WHO standards. So WHO standards, there were one set of standards that were set in 2005, and then they were revised in 2021, right? So you can see how, see the difference between the WHO standards and Indian standards, right? So here, the blue ones are annual mean, right? When it comes to PM 2.5 in 2021, it was set to 5, and you can see what India has set it as, right? It's as high as 40, and the 24-hour mean is 15, whereas India has set it as 60. So we are sort of, we've overshot the recommendations by WHO, but this is considering the fact that we have several aspects to also additionally think about. It's not just about human health or equality for us, it's also about development. If we end up actually compromising and ensuring air quality, it might come at a huge cost for development, which might end up being crippling for the economy. Uh, as a consequence, we might actually lose out uh, on the capacity to even, sustain basic needs for the society. There have been examples of this, uh, where countries have sort of, leapt forward. Affording a green lifestyle or an environmental friendly lifestyle is quite costly, quite expensive. And yes, the developed countries have started moving towards it, and rightly so, because they can actually afford to do that, right? However, a few developing countries that sort of, take the leap saying, okay, we are also going completely green, we'll also, adhere to these standards. They either lack the technology to do so, which means they have to make expensive technology purchases. But leaving that aside, even otherwise, what happens is their practices, it becomes costly for the people, or it becomes costly for the government to sustain. Some, like, it's not a sustainable model, right? Which is why India has gone for a more realistic standard where we have struck a balance. For a couple of these pollutants, we have actually adhered to the WHO standards. So, for example, ozone. Yeah. So when we see ozone, we have these um, peak season ozone to be, uh, sorry, 8-hour mean to be 100, right? And we've also set the level to be 100. India standards is also 100. And for carbon monoxide, the 2021 WHO standard recommends 4. We have a more stringent standard of 2, right? So that's just to give an idea of where the in national ambient air quality stands, right? So an essential aspect towards, estimating this air quality is the presence of air quality monitoring stations. And India uh, sort of heavily falls short of the required numbers. So you can see the This is a few years ago. This is from a few years ago. This is from, I think, 2017 or a little before that. These are all the air quality monitoring stations. You can see vast stretches that are unmonitored. There is always this justification that might come up saying, those are not inhabited lands. But nonetheless, for example, in Tamil Nadu, you can see a vast gap, right? Like there are several cities in the state, spread throughout the state, and you don't see enough air quality monitoring stations. Furthermore, there is a difference between the normal monitoring stations and there are these continuous air monitors, CAMs, right? As of September 2017, we have 74 CAMs in 43 cities and 16 states, right? So if we take a look at the dashboard, so this is sort of the pollution level, the level of pollutants in different cities in India. We have these manual stations, continuous stations. So if you see, Bhubaneswar has 5 manual stations, no continuous stations. So this is where the shortfall lies. However, we need 22 stations in reality, right? So India needs to sort of ramp like up its air quality monitoring game, and we need to install more monitors for a more accurate estimate of what the actual air quality is, right? All right. Moving on to the next question. Since a couple of you have joined, um, I would request you to post your answers in the chat box, like as and when we move move towards the next questions. If you have any queries, you can always raise your hand and unmute and ask the question once I prompt you to, or you can also type your questions in the chat box. So we are currently looking at the assignment questions from the previous run of the course. So the last time the course was offered, not the current assignment yet. So moving on to the third question. For scoping process in EIA, a particular atmospheric pollutant will depend on, we have 4 options. A, nature and scale of the development. B, sensitivity of the receiving environment. C, baseline conditions of the area under study. And D, all of the above. Any responses? Yeah, I can see a raised hand.
I think D.
Okay. Any other responses? There's one more person, right? All right, you are right, sir. So the answer is D, right? So, ma'am, there is no particular slide that actually talks about this in detail. So, but ma'am sort of, she mentions it as the slides pass by, right? So, yes, you are right. So, moving on to the next question. On what basis the selection of the equipment to measure air pollution is done? A, intended use of the data. B, budget allocated to purchase or hire the equipment. C, expertise of personnel available to set up and maintain the equipment. And D, all of the above. You can also directly unmute and respond. You don't have to worry about it since it's very few of us. Any responses? All right. So this is actually directly taken from ma'am's slides. So these are the 3 aspects: equipment to measure air pollution concentrations based on, right? So we look at the intended use. What are you going to use the data for? So what is the budget allocation? And are there personnel, like are there people to operate these machineries and maintain them, right? So the answer is all of the above. Any queries? All right. So moving on to the next question. Identify the model shown in the image used for impact prediction and evaluation of air. So we have A, wind tunnel and physical scale model, B, passive diffusion tube and physical scale model, C, pneumatic tube and physical scale model, or D, all of the above.
C.
Okay, okay. Any other responses? Okay, so the answer is actually A, wind tunnel. So this entire setup is actually a wind tunnel. Okay? And this is the physical model that we're talking about. So this is from the slide, and the PDF actually has links to this particular project, right? So the answer is A, internal and physical scale model. But again, let's take a closer look at what happens in this setup, right? So this is Wotan. It's a wind tunnel in the University of Hamburg, if I'm not wrong. So you can see how big these wind tunnels can be. What we do is we sort of build physical scale models. We keep them in these tunnels, right? And the anchoring, if you can see, there are these points that sort of simulate the anchoring, like they keep the model in place, right? And then the direction of wind is determined, and accordingly the model is placed. And then we sort of simulate the wind to figure out where can there be excess wind. So there are certain projects where we might end up affecting the wind flow pattern, right? There's something called Venturi effect. So if you remember, as architects, if there's air coming in from like a larger gap to, I'm drawing plans here, right? So say there are 4 buildings in this configuration, and if there's air flowing here, what happens is as it flows from a larger volume to a narrower volume, the air speed is actually increased. So we need to take such things into consideration because I mean, breeze is fine and wind up to a certain speeds is fine, but it's not good to have continuous winds and to have it, blowing all the time, right? So this is sort of a plan, and the top one is a plan and the bottom one is a section. You can see, so they've kept this model here. This is the model, physical model, and this is the inlet tunnel, and that's the outlet tunnel. It's almost 7.2 meters by 10.5 meters. This is the section. You can see how this is the flow. They have sort of mentioned the flow, and then you can determine there's an adjustable ceiling, and this is the basic tentative setup, right? So when the wind flows, the height also needs to be, so that the height doesn't sort of interfere with the flow and modify our readings, right? So apart from wind flow, we can also determine the movement of smoke, right? So in this project, what they've done is this. So this is the rubble pile. Say that there's some sort of incineration happening. So they sort of visualize smoke. Right? The other use for such tunnels is the vertical light sheet. So because it's a closed setup, you can also simulate the kind of light, like especially at night time, what kind of effect is it going to have, right? Is there any query regarding this? All right, let's move on to the next question. State true or false. With numerical dispersion models, we can calculate how specified emission rates are transformed by the atmospheric processes into pollution concentrations at different distances from the source or sources of the pollution. Is it true or false? So the question is about numerical dispersion models. And using this, the statement is that we can calculate specified emission rates, right? And how they are transformed by atmospheric processes, right? What they mean by this different distances from sources is, say this is the source, this is your area that you're, you know, evaluating. From this source, can the numerical dispersion model help you to calculate what the pollution will be at different points in the settlement? Like here, here, here. Is it true or false? Any responses? Okay, so it's actually true, right? So using these, so the name itself is sort of self-explanatory. It's a numerical model, which means it's a calculating mathematical model, and it helps model dispersion, right? So using the model, we can calculate how specified emission rates are transformed by the atmospheric processes into pollution concentrations at different distances from the source or sources of the pollution, right? So this process is also called as, so say you're taking several points for air quality monitoring, but how will you figure out the values in between? So those are called interpolation models, right? We sort of create what we call a heat map, which is a different kind of model. So here there is a source of pollution. From this source, how is it going to spread? How is it going to disperse, right, in all directions? So that's the numerical dispersion model. So the answer is true. Any queries? Right, moving on to the next question. Match the following term from group A with their description in group B. So in group A, we have examples in relation to prediction of pollution concentration for emission, right? So we have single point source, large number of point sources, area sources, and line sources. And group B sort of gives examples of those. So we have ponds, settling tanks, open cast mines or quarries, industrial stack or vent, open roads, street canyons, railways, construction sites, car parks, motorway stations, etc. Any responses? You can also give me individual responses if you don't know the entire answer. Yes, sir.
D.
Okay. Okay. So let's see what the answer is, right? Okay. So first one is ponds, settling tanks. So these are all. Mm, wait 1 second. Open industrial stack or vent will sort of be a single point source, right? So there is a single vent. So P2. Open roads, street canyons, railways are all, you know, if you see in a map, there are these lines that go through. So they are line sources, right? So the only difference between ponds, settling tanks, open cast mines, and construction sites, car parks are the relative size. So we usually represent these as areas and we usually represent these as points. Okay, so when you say, oh, this is a gas station, you mark it as a point. You don't mark its area, like, at least for the purposes that we are talking about. So these are large number of point sources and R is area source. So P2, uh, Q4. Okay, there is no response only actually. I think this was raised in the discussion forum also. According to the key, it's given as B, but it's actually P2Q4, right? Uh, Area sources will be R1 and S3. So for this, I will sort of get back. So this is, I'll clarify this with the team and I'll post in the discussion forum regarding this, right? But looking at what the slide spoke about, so we spoke about how if there is a single vent, so this is the industries, ventilation stacks. These are these huge chimneys that we see in the industrial areas. So they are sort of single points, usually, right? Unless and until it's an extensive, huge industrial area, then yeah, they are a collection of points. But usually they are single points, and we'll consider them as single points, right? So looking at a study that sort of dealt with all three kinds of data. So this was a research where they projected the air quality in Vienna between 2005 and 2020 for nitrogen dioxide and particulate matter 10. Right. So they have several types of data. They had topography data, meteorological data, traffic data. So what happened was they had they ended up having three of them. So they had several point data, they had line data, and they had aerial data. Right. They sort of had to integrate all three of them, and then they had to sum over them through certain methods in order to do their assessment. Right? It's not as straightforward as we think it is. We can't just add points and lines, right? So, so they sort of directly correspond to the kind of spatial data types that we have in GIS. GIS is Geographic Information System. Like we have these software like ArcGIS, QGIS, and there are several other open source software also. So these sort of become the building blocks or this basic elements of GIS, and it's a consequence of this, right? Because what we try to model in GIS is sort of the real world, right? So therefore, we have these three components of point data, line data, and polygon data. Polygon data is basically area data, right? So these directly correspond to, so this is, sorry, it's mildly cut here. It's street data. I'll correct the diagram later. Street data with buildings data and vegetation data. This is usually in terms of areas. These are points and lines. We integrate them to create a layered map. Right? I hope there are no queries there. It's a straightforward thing. Right? Moving on to the next question. The equation of return period or recurrence interval, which tells us the chances of the same flow of rain increasing in a year, is written as, we have four options. Return period is equal to 1 by P. B says it's equal to P by 2. C says it's equal to P by 4. And D says return period is P by 6, where P is the probability of exceedance. Any responses? All right, let's see what the answer is. So the return period or recurrence interval is actually the most common way of showing the chances of the flow or rainfall event to occur. So say there is a flood, right? We have these things. If you go to most lakes or some kind of water bodies, especially those that have been maintained well, you can see these 100-year flood line or 50-year flood line. So what is the 100-year flood line? Essentially, that's the highest line to which flood sort of happened in the past 100 years, right? There will also be a 10-year flood line, right? So that will usually be lower than the 100-year flood line, or at least as much as the 100-year flood line. Can't be more than the 100-year flood line, because then that will become the 100-year flood line. All right. So what happens is when you're marking the 10-year flood line, there is, so every year when there is rain, there is there is no guarantee that we'll have the same amount of rain falling every year, right? It's usually varying. It's usually increasing or decreasing. We are more worried about the upper limit because then there are chances of flooding or some sort of disaster happening, right? So this return period sort of estimates what is the probability that this year we'll get such an event, right? So it's based on historical data, and the return period is actually calculated as 1 by P, right? So the answer is A. Any queries regarding this? All right, let's move on to the next question. Correct formula of Thorndike and method to estimate water budget is, like, there are four equations. So we have P as precipitation, R as surface runoff, G as groundwater flow, ET as evapotranspiration, and delta S as the change in storage in a specified time period. So any responses as to which the correct equation is? Okay, so this is actually a very famous method to estimate water budget. So this method, they sort of published, this book is called The Water Balance, right? And it's one of the major methods to estimate how much water, how much change is there in the storage, right? So we can remember this sort of logically. So how will we determine? So there is an area. Uh, so the incoming water to this area is usually through precipitation, right? There might be other sources also. Those were considered in other models, but they originally did not propose it. That's why we are not looking at them here. But there could be other sources also. Say there is a river flowing through, right? So that could also be a source. Nonetheless, so we have precipitation. Precipitation meaning rain, snow, etc. So this is our P, right? What are the so if this, how much water is being stored here? It's basically whatever is coming in minus whatever is going out, right? So what are the things that can go out? There can be surface runoff. So what happens is water does not percolate enough or stay, it sort of runs out of the area because of the soil characteristics. Maybe it's impervious, maybe we have paved it, maybe the speed of the water is such that it sort of flows off, right? There is also groundwater flow, so some of it goes into the ground. It sort of percolates into the ground, right? Some of it goes off in evapotranspiration. So what is evapotranspiration? Like it was explained in the slides. So it's either evaporation, say there is a water body here. From the water body, there is evaporation. Or if there is a tree, right? So these trees sort of lose water in the in a process called transpiration, right? So they take water from the ground and sort of let it go. Yes, sir, your answer is correct. The answer is C, right? So, so the incoming aspect is P, and we have three outgoing aspects: minus R, minus G, and minus ET. Right. So this is G, this is ET, and this is R. This is delta S. So that's the easiest way of remembering this equation, right? So this is sort of the slide that talks about this, the water budget, right? So the answer is C. So this is a depiction of the hydrological cycle. So like we said, we have precipitation, but we can also have other sources of water, right? So, sorry. So we can have some sort of surface water inflow also, but these are not calculated in this model, right? And when it's going out, we have groundwater outflow also, surface water outflow. This is surface runoff, and we have evapotranspiration. Right? So, ma'am also mentions this word watershed when she's talking about this. So, what is a watershed? A watershed is an entire area which is drained by a common set of channels. So what happens is, say there is a hill here or a peak here. When it rains, all the water that is falling on the right side will sort of go towards this watershed. Whatever is falling this side will go towards this watershed. This water will never come this way, right? There's no possibility that water will go against gravity and then come here. So this doesn't happen. So this area is called a watershed. And if you can see here, so this is the ridge of the hill. We call this the water divide. Okay. So everything that falls in here sort of gets drained by this particular river. So this entire area is called a watershed, right? So this one will be a separate watershed, this one will be a separate watershed, and this one is a separate watershed, right? So I hope that's clear. Any queries regarding this? All right. Moving on to the next question. Match the following terms of group A with their description in group B. So we have four terms, one of which we just saw. Right? So we have evapotranspiration, bed load, fluvial geomorphology, and geomorphological threshold. Any answers?
A.
Okay, we have one answer. Any others? Okay. Let's see what the answers can be. So in group B, we have the first description. So riverbed particulates which range in size, such as they could be silts, coarse sands, gravels, or even boulders. So if you remember, ma'am talks about this when she talks about the physical attributes, right? So of surface and groundwater quality, right? So that will be bed load, right? So Q is one, right? We have. So then we have a condition allowing landform stability, a dynamic equilibrium through many factors playing their coordinated role. So whenever we talk about equilibrium and stability, we sort of talk about this geomorphological threshold. I'll explain it a bit more a little later, right? So, but this is a geomorphological threshold. So at this point, it sort of comes to a point of landform stability. Okay. Like I said, I'll explain it a bit more slightly later. Then the third point, combined loss of water vapor from the surface of plants, just transpiration, and the evaporation of moisture from the soil and other surfaces such as lakes, rivers, and oceans. Like we just saw, that's evapotranspiration, right? So that's evapo and transpiration. So there are two words that are put together. So we have transpiration and evaporation. And the fourth one is processes of water and sediment movement in rivers and their floodplains together with the forms produced by these processes. So such processes are usually dealt with by, they are studied in fluvial geomorphology, right? So it's both uh, water and sediment movement, and they end up creating certain landforms. Okay? So those two, the study of these things is called fluvial geomorphology. So, so these are the slides that deal with these four aspects. Right? You can see it's from grass, from water bodies, also from trees. That's transpiration and then evaporation as well. That's evapotranspiration. Bed load, she talks about when she's talking about physical attributes of surface and groundwater quality. So fluvial geomorphology, it refers to the process of water and sediment movement, right? So and the forms that are produced by fluvial geomorphology. And we have this geomorphological threshold. So the answer is D, but let's go a little bit deeper. So whenever there is a river, we can see that the river sort of is like the movement of water and the sediments along with it. Like whenever the river flows, it sort of brings down sediments or sometimes even bigger particles or even boulders at times, sort of brings it down. You can see that it leads to the formation of various landforms, right? For example, the flow of water here sort of has created the valley. It's back and forth. Obviously, there was a depression here that allowed the flow of water here, but also as the water flows, it changes the landform also, right? So you can see how there is very high levels of velocity in these areas. So water comes down with a great speed. So it's like a linear stream, but as it reaches the plains, it sort of the speed reduces, and therefore this is called meandering. Okay. So when we look at all these, several types of formations and the movement of water, that's called fluvial geomorphology. For example, like we might think, oh, is that all? It can actually lead to several types of formations. This is just one example of a particular Chaco canyon, right? You can see the number of formations that the flow of this particular river has led to, right? So these are just some terms. If you're interested, you can go ahead and check them out as well. So, but what is a geomorphological threshold then? So there is a point beyond which the form of the river starts changing, right? So say the river was both in time and in place. So if you take a look at this diagram, for example, here it's in a different form, here it is in a different form, here it's in a different form. This break is sort of what we call the threshold, right? So it sort of leads to a sort of an equilibrium where it it ends up. So right now the river is flowing in a particular way. If you've grown up near river systems, you will know that the river changes its course over time. uh, the changes sort of happen over a very long period of time. At the moment they are stable, right? So that's called a geomorphological threshold. So this is an example. So they can happen both in time or through space, right? So maybe over time it evolves to a certain formation, or even across the river. For example, this Buffalo Slough is sort of the old pathway where the river was flowing previously, right? One of my most favorite things is the Oxbow Lake formation. These Oxbow lakes actually look really beautiful. So as the river starts flowing, like I said, the river starts meandering, right? So it sort of starts going in this shape. But as this keeps happening, the flow of river sort of cuts this part out. So there is a shorting that happens here, and an arc or an oxbow shaped lake sort of forms here. They're extremely beautiful phenomena. Do take a look at one. Like even in this image, you can actually see this is an oxbow lake, right? That's sort of to introduce what a geomorphological threshold is. That being said, you'll have to remember this sentence, right? Any queries regarding this? Okay. Uh, okay. Before we move on to the next question, let's take a short break for about 5 minutes, because the next question has a bit of explanation following it, right? So it's 7:01 in my system right now. Let's meet back at around 7:07. That's all right with you. Right, I'm unable to. Yeah, right. Let's resume with the session. So, question number 11. Name the type of soil order as shown in the image, which typically occur more in cold and wet higher ground, on wide and relatively flat interflows, and in low-lying receiving sites. So you need to name this the type of soil order. Is it A spodosol, B oxisol, C aridisol, or D histosol? Any responses? Okay, so if you remember from the slide, it's actually spodosol, right? Ma'am, in fact, talks about how it typically occurs more in cold and wet higher ground, on wide and relatively flat interflows, and in low-lying receiving sites, right? So the answer is A, spodosol. 1 second. Alright, so I'm not able to join through the chat. So, like, if you have responses or queries, please unmute yourself and ask. Right? Uh, yeah, my chat box is open now. So let's take a look at what do these terms mean, like spodosol, oxisol, where do they come from? So there is something called the USDA soil taxonomy, right? So this is taken from Wikipedia. This soil taxonomy, a taxonomy is a classification system, right? So you sort of describe what are the types of things, right? So here we have a soil taxonomy, as in we describe the types of soils that are present. So this was developed by the United States Department of Agriculture and the National Cooperative Soil Survey. It provides an elaborate classification of soil types according to several parameters, right? And there are several levels also. So right now we are looking at soil order. Right? This classification was originally developed by Guy Donald Smith, that's his name, former director of the U.S. Department of Agriculture Soil Survey Investigations. There are 12 soil orders, right? Like at this level, there are 12 types in the soil taxonomy. All right. So in the slides in the lecture, we saw just two of them. We actually have 12 of them, right? So this is the full list of uh, full 12 types, 12 soil orders that are present according to the USDA soil taxonomy. So there is alphisol, andisol, aridisol, entisol, gelisol, histosol, inceptisol, mollisol. Oxisol is what we saw in the slides too. Spodosol, ultisol, and vertisol. So, in fact, in terms of development, the least developed one is entisol, and the highly developed ones are oxysols. Right? You can see how spodosols are sort of sporic, cold, wet, sand, acid, coniferous forests. Right? That's where these are present usually. So this is a map of the global soil regions. Right? So you can see how India has a lot of these alphisols, vertisols, right? Some ultisols. There's a bit of orange. So India has quite a few of these. Right? So these are the soil orders that are present in India. So the pink areas have alphisols in combination with inseptisols or in combination with entisols. You can see how in India the categories are not so clear, right? So in fact here you can see there are different types of mollisols present. Right? So this is according to the USDA soil taxonomy. Correct. However, when you look at the system that we use in India, we usually use this particular classification: alluvial soil, black soil. Like these are terms that you must be very familiar with, right? Loamy soil, lateritic soil. This is the usual classification that is employed in India. However, if we classify India's soils according to the USDA soil taxonomy, which has these names, right? Like aridisol, lentisol, all of these. So that's the map that you get, right? Any queries? All right. Moving on to the next question. Match the following type of map with their significance. So we have two maps: solid maps and drift maps. Any answers? We have one answer. Any others? All right, you are right, sir. So the drift maps actually show superficial quaternary deposits that have been laid down more recently. So the recent ones are drift maps. Solid maps actually show only pre-quaternary rocks, right? So that's the slide that deals with this. But this is an example of, solid and drift maps. So this is a drift map, right? Why? Because it sort of describes what is in the topmost layer, right? And all the cross sections sort of point towards the solid map. So they're usually available as a set in, like, they complement each other in describing the areas. This is just an example. You don't have to worry about what is there. So these are the, like, this is a cross section and then several layers underneath, right? So that's an example of solid and drift maps. Any queries? I hope not. So it's just to, sort of illustrate. Moving on to the next question. State true or false. FAO guidelines for land evaluation provide a set of principles and a methodological framework for assessing impacts in compliance with the UN programs for sustainable development. Is it true or false? We're talking about the FAO guidelines for land evaluation. We have one answer, and you are right, sir. So it is true. So this is the slide. Yes, both of you are right. So this is the slide that sort of gives you this content, right? It actually gives a set of principles as well as a methodological framework, right, for assessing impacts. So the answer is true. Okay. My chat box has crashed again, so just give me 1 second. All right. Moving on to the next question. Okay, I can't open my. I can't open my chat box, so like you can just unmute and answer. Right? So match the following terms of Group A with their description in Group B. So we have four terms: climate change, vulnerability, climate projection, and adaptation. And these are the descriptions. Do we have any answers? You can also give me individual options. Kindly unmute and tell me because my phone has, like, I'm restarting my phone.
A.
Okay, one answer, A. Any others? Okay, let's see. So the process of Under group B, the first option is the process of adjustment to actual or expected climate and its effects. Right? So, if you remember, we briefly sort of dealt with these aspects in our second week session as well. So, when you talk about adjustment to actual or expected climate, that will be adaptation, right? And the second option, the simulated response of the climate system to a scenario of future emission or concentration of greenhouse gases and aerosols, generally derived using climate models. So here the keyword is simulated, and it's a scenario of future, right? So that will be climate projection. All projections are usually scenarios or some sort of, we project as to what might be the case in future. Third option, a change in the state of the climate that can be identified by changes in the mean and or variability of its properties, and that persists for an extended period, typically decades or longer. So that will be climate change. Right? And fourth one, the propensity or predisposition to be adversely affected. So adverse, they have a tendency to be affected more. Right? So that's vulnerability. So we have P3, Q4, R2, and S1. So the answer is actually B. Right? So these are the slides that deal with these descriptions. So the answer is B. Any queries regarding this? All right. Moving on to the next question. Question number 15. Match the following terms of Group A with their description in Group B. We have yet another set of four uh, terms, right? So we have adaptive capacity, carbon sink, greenhouse gases, and mitigation of climate change. Any answers? All right, let's look at the options again. So, Group B, the first one, a human intervention to reduce the sources or enhance the sinks of greenhouse gases. So, here we have an intervention to reduce the sources or enhance the sinks of greenhouse gases. So, we're sort of doing something to, make the situation better, right? So, that will be mitigation. All right. So, when we have the ability of systems, institutions, humans, and other organisms to adjust to potential damage, to take advantage of opportunities, and to respond to consequences. So it's not just about adjusting to potential damage, but also take advantage. So something goes wrong, and this the instead of affecting the system actually takes advantage of it, right? So that is called adaptive capacity. Right? Where's my cursor? This again we saw uh, in our second week lecture, if you remember. Right? So the third one, any process, activity, or mechanism that removes a GHG, an aerosol, or a precursor of a GHG or aerosol from the atmosphere. So this is a sink, a carbon sink, because greenhouse gases essentially contain carbon, and a carbon sink is sort of like a sink, like just like our water sink where things go in, right? So that's the concept. So it removes a GHG, an aerosol, or a precursor of a GHG or aerosol, right? So the fourth one, those gaseous constituents of the atmosphere, both natural and anthropogenic, that absorb and emit radiation at specific wavelengths within the spectrum of infrared radiation emitted by the Earth's surface, atmosphere, and clouds. So these are the gases, the greenhouse gases, right? So they sort of absorb and emit radiation at a specific wavelength, within the spectrum of IR, infrared radiation, which is usually emitted by the Earth's surface. So this is from school science. This is called the greenhouse effect, right? So Earth is there, and these greenhouse gases sort of trap the heat that is being emitted, like reflected off the Earth's surface. So these gases sort of do this trapping, right? So the answer is P2, Q3, R4, and S1. So the answer is A, right? So these are the slides that sort of deal with these four. Okay. So before we move on to the current week 7's assignment questions, which I'll run through very quickly, because I would like to show a few resources towards the end of the session. Are there any queries from the taught lectures or any other general queries? All right. If not, then let's move on to the these questions. I will not be prompting much for answers because you must have just answered these questions in your assignments, right? So, question number one: what are the effects of air pollutants? Causes inflammation, sensitize and scar the airway. Sorry, it's very badly worded. Can affect lungs in extreme conditions because of the long duration of exposure. And pollution can reside permanently in the body. Impact can vary from irritation, serious illness, or even early death in some cases. So the answer is actually all of the above. This is the slide that deals with it. It's in the first lecture of the week, right? The answer is D. If you have any queries regarding any of the answers I'm discussing, please interrupt me. We can have a more detailed discussion, right? So moving on to the next question. State true or false. Air pollutants critical levels is defined as concentration of the pollutants in the atmosphere above which direct adverse effects on the receptors such as human beings, plants, ecosystems or material may occur according to present knowledge. So again, we're looking at a concentration of pollution in the atmosphere, right? So that is critical level, right? So the answer is true. So this is the slide that gives you the definition of what a critical level is according to UNEC 1996. Right? So the answer is true. Moving on to the next question. International Finance Corporation IFC provides Performance Standards 1. It is an international benchmark for environmental and social risk management. Is it true or false? So, as I had said in the previous sessions as well, these standards by IFC and Development Goals, all of these lists are things that you like inevitably have to remember, right? So, this is the slide that sort of shows what all eight IFC PS1 performance standards are. And PS1 deals with risk management, right? So, environmental and social risks and impacts. So, the answer is true. Okay. So, moving on to the next question. Match the following types of impact prediction and evaluation models given below. So, in group one, we have the types of impact prediction and evaluation model. The group two sort of gives a description of it. So, the first one is P, numerical dispersion models. Q is simple screening models, which is a subtype of like which is a type of numerical dispersion model also, right? And we have the Gaussian model as R. So in group two, option number one, this model considers the pollutant emission spreads outward from a source in an expanding plume aligned to the wind direction, right? So the answer for this is one second. Yeah. So this is actually the Gaussian model. So this is the model that we saw where there is a industrial vent or a stack, chimney stack, from where there is emission, and we sort of, there is a cone shaped dispersion that happens, right? Okay, so the second one, through this model, you can calculate how specified emission rates are transformed by the atmospheric process into pollution concentration at different distances from the source or sources of pollution. So, like like we spoke about earlier in the session, this will be the numerical dispersion model. The third one, in this model, simple assumptions are taken about the behavior of pollutants in the atmosphere. They can be used with the limited meteorological input data, such as minimum and maximum ambient air temperatures and minimum wind speed, with which worst case pollution concentrations can be estimated. So, this is sort of like an initial or a basic estimation, like a rough estimation, right? So, that is simple or screening models. So, we have P2, Q3, and R1. So, the answer is actually C, right? So, these are the slides that sort of deal with this. Any queries until now? I hope I'm still on. Right. Yeah. Okay. Moving on to the next question. Match the following order effects assessment models. Right. We have three options. One is risk-based assessment. The other is semi-quantitative assessment, and then there is dispersion modeling. So in group two, the first one, odor concentrations are predicted and compared to the benchmark values. So this is the keyword. What are the accepted values, and we compare with that. Which are the accepted values? These benchmark values are the accepted values. We sort of compare with that and predict. So this is the semi-quantitative assessment, right? So some sort of assessment or benchmarking has already been done. What we do is we compare with that and figure it out. So the second description is where we look at the pathway and the receptor and then we draw conclusion. Okay, so I think there has been a mistake. Okay, so lookup tables is actually given separately. So this is probably, there is a bit of high ambiguity here also actually. Now that I'm solving it with you people, it's clear, right? This is another question that I'll sort of get back to you about. This is clear, right? So when we look at the pathway and the receptor and then we draw a conclusion, that's risk-based assessment. Uh, Technically, these two are the same option, right? So there is some inherent contradiction here. So I'll get back to you with, I'll post it in the discussion forum. Right? Moving on to question 6. I mean, do you have anything to say about this? I find a contradiction, or am I wrong? Because dispersion modeling is usually when we sort of do detailed calculations, right? All right, I'll get back to you on this. I hope I'm still audible in
I
this
that is why I had written the first as the I don't know.
answer, right?
Yes,
Yeah,
yes,
yeah.
yes.
Yes, sir. So what I'll do is I'll sort of get back to the team on this saying it's ambiguous, right? And they'll either change the answer key, or like they'll usually, if there is an issue from the question from their side, they give marks for that, right? So yeah, so hopefully I'll get back to you on this. Okay, moving on to the next question. State true or false. So ADMs, ADMS, EPA's Cal 3 QHC, Calin 4 modeling are used by different countries for road traffic air pollution modeling. Is it true or false? So it is true. So these are sort of listed in the slide, right? So ADMS is UK's, uh, Cal 3 QHC is US's, uh, this Environment Protection Agency's model, and we have the Calin 4 models, right? One second. All right. So this is true. Moving on to the next question. Match the following. Surface and groundwater quality is determined by assessing three classes of attributes. So, if you remember from the from earlier from the lecture, we spoke about these physical attributes. For example, bed load, right? So, since ma'am hadn't given any solid description in the slides, you can actually go ahead and use these descriptions only once they've been matched properly. Right? So we have three options. We have physical attributes, biological attributes, and chemical attributes, right? In group two, the first option is the dissolved chemical solutes, which originate from atmospheric soil or weathering of bedrock. We need to understand the water is never pure. So we have these dissolved chemical solutes, right? So as the name suggests, this will sort of be the chemical attribute of the surface and groundwater quality. The second one is natural waters vary in the amount of particulates and materials, right? It's actually particulate material. Okay, so there's no S. Particulate material present in them. Rivers typically carry large quantities of particulates. So these are actually physical matter, right? So these are these will be the physical attributes. Okay. So the other one, the third one, are used to describe the presence of microbiological organism and waterborne pathogens. So many of these can cause health issues for humans and animals. So this will be the biological attribute. Right. So we have P2, Q3, and R1. So the answer is C. So like during this slide, ma'am sort of explains all three of them. Right. The answer is actually C. I hope I'm still on call. Yeah. Any queries till now? One second. I'm sorry, there is some issue with my Google Meets. That's the issue. I'm not able to connect from my phone. All right. So that's settled. So the chat box is available again in case you need to raise anything or say something, right? So, all right. Coming back, going on to the next question. Right? So, state true or false. Water quantity assessment through a desktop study involves catchment boundary area and drainage pattern and information on geomorphology such as slopes, geology, soil, and land use, which can be determined from the base maps, geological and soil survey maps. Is it true or false? So whenever it's a desktop study, the essential aspect is that you are not on field, right? So, which means all the sources of data will be secondary data. Right? So, which this is the key, which can be determined from the base maps, geological and soil survey maps. So, the answer is actually true, right? That's the slide that sort of outlines it. Usually, quantity assessments are there are several agencies that must have carried out some sort of evaluation. So quantity assessments uh, have improved in it that uh, right now even satellite data is actually being used to sort of predict the amount of groundwater levels and stuff. But quality assessments will be more difficult if there is no prior work that has been field work that has been done. So that's the major difference between quantity assessment and quality assessment, right? Usually for quality assessment, we end up going to the field. All right. For the next question, match the following. We have base flow, return period, and drainage basin approach. So, if you remember, so we had this approach for the water budget, right? The Thornwright and Mather approach. The drainage basin approach is the other approach that we can use to calculate the water budget or the water balance, right? So, we have three options here. One is in this approach, catchments are separated by a watershed boundary. So that's our Q, right? Which is a natural division line along the highest points of land, precipitation that is rain, snow, and so on. So we saw watersheds, what watersheds are early on, right? So this is the drainage basin approach. So whenever there is a big area, we sort of determine, the drainage basin. So say this is draining towards one side. This area, I'm drawing a very mm, tentative drawing, right? So, say this whole area is draining somewhere else. Say it's going there, draining there. This is a peak. Say this is a ridge of a mountain, right? So, this area is draining here. This area is draining here. This area is draining here. So, these are all watersheds, right? They're also called catchments. Uh, when we determine this and then we sort of go to take an approach towards calculation of flow or hydrology, then it's the drainage basin approach, right? So the second one is return period, movement of water between the surface body and the groundwater. So that's the base flow. So it's actually the movement of water between the surface body and the groundwater. Then the third option tells us that chances of the same flow of rain increasing in a year. So this is the return period, usually given by 1 by P, where P is the probability of exceedance, right? So it's P2, Q3, and R1. So you are right, sir. Mm, you've given the answer in chat box. You are right. So, right. So these are the slides. Let's sort of deal with these. The answer is C. The next question. Match the following. We have cover. So this is about scale of assessment, right? So we have cover large areas as a whole continent, as large as a whole continent rather. Then we have regional maps, and then we have details. So we have one is scale is 1 is to 20 million, scale is 1 is to 1 million, and between 1 is to 25 to 50,000, right? 2,50,000. So then we have scale 1 is to 10,000. So this scale is sort of the most detailed scale, right? So this will be the R will be 3. The regional map sort of is somewhere in between. The largest scale will be the whole continent, right? So be P1, Q2, and R3. Any queries thus far? I'm sort of rushing through so that we can take a look at the additional materials as well. Alright. So moving on to the next question. Field survey of land soil involves on a requirement to collect baseline information on land and soil from field survey. Information such as landform, soil types, land quality, ground cover, land cover and tenure. GIS for spatial and statistical analysis, and history maps. So which of these? So this is the slide that sort of points to what all are involved in a field survey, right? So history maps are usually not involved in a field survey. One second. Okay. So moving on to the next question. State true or false. To estimate the soil pollution, two types of situations exist when wherein EIA. So one, the site is already contaminated and a cleanup operation is required. And two, soil pollution may be caused by the project itself. So either the site is already contaminated, right? Then you'll have to deal with the contamination, or two, the pollution might be a consequence of the project itself, right? So whether this is true or false, this is true. So these are the two cases, situations that exist sort of when we go for an EIA, right? Regarding soil. So the answer is true. Moving on to the next question. State true or false. Greenhouse gases are gases constituent gaseous constituents. Sorry, that's are gaseous constituents of the atmosphere that absorb and emit radiation at pardon the English, that absorb and emit radiation at a specific wavelength within the spectrum of infrared radiation emitted by the Earth's surface, atmosphere, and clouds. So, am I not connected? Am I audible? I am audible, right? Okay, yeah, I think I am audible. So, like we saw earlier in the session today, this is in fact the definition of the description of greenhouse gases. Right? So these are some examples of greenhouse gases. We have water vapor, carbon dioxide, nitrous oxide, methane, and ozone. We sort of need them at a particular concentration, but beyond a point, contributes to global warming. So the answer is true. Moving on to the next question. Match the following as per EAA context. So some of these we already saw. We saw mitigation and we saw climate change. The new option is resilience, right? So for the first one, a human intervention to reduce the sources or enhance the sinks of greenhouse gases, like we saw, it's mitigation, right? Any process, activity, or mechanism that removes greenhouse gases and aerosol or a precursor. So again, we actually have. So this option is actually wrong, right? This is a carbon sink, if I'm not wrong. So none of the answers actually match. So any process, activity, or mechanism that removes greenhouse gases and aerosol or a precursor of greenhouse gases and aerosol from the atmosphere. We just saw that this is actually a carbon sink. So again, this question, there are several questions that sort of need clarification. I'll get back to you on this, right? I'll post the clarifications both in the description in YouTube as well as in the discussion forum for the course. The third one, capacity of social, economic, and environmental systems to cope with a hazardous event or trend or disturbances, responding or reorganizing ways that maintain the essential functions, identity, and structure while also maintaining the capacity for adaptation, learning, and transformation. So here, basically, it's more like the system sort of somehow manages to cope with a disturbance, right? So that's resilience. However, usually what happens is when we saw adaptive capacity, when the system takes advantage of the disturbance, that's adaptive capacity. So that's the difference between resilience and adaptive capacity. Again, this has been sort of outlined in the week two interaction or live session. Right? So this is so climate change should have been actually this, right? This was given as the answer. So we have QS3 and PS1, but R is not 2. So you could have logically answered this, but yeah, there is an issue with the question itself. Okay, so moving on to some additional content. Before we move on, are there any queries, general queries, or any queries regarding the current assignment? I'll sort of take note of these issues that have been there, right? There are a couple of questions where there are issues, but apart from that, any queries? All right, let's take a look at these, right? So when it comes to environmental impact assessment in India, there are a few relevant documents that are important, right? Like the from last week's session, we had mentioned TOR. If you remember what TOR is terms of reference, right? So these documents are originally supposed to be available in this link, environmentclearance.nic.in. But what happens when you go to the site is most of the links sort of don't work. All right. So very unfortunately, most of them turn up with an error, right? Some of them might be working, but most of them aren't. So alternatively, there is this other link that I've shared with you, right? So this is called parivesh.nic.in. So Parivesh is actually an initiative of the government of India. It's the proactive and responsive facilitation by interactive and virtuous environmental single window hub. So you can sort of get all documents in a single place. That's the idea of it. Right. In this website, if you see, you can get all these documents that are actually missing from that website. So we have these, all the EIA notifications, circulars. We have the standard terms of reference, guidance manuals, right? The draft EIA notification from 2020. This is the standard terms of reference for, so these are for individual projects and this is the overarching one, right? So these are the terms of reference for individual, like separate sectors. For example, mining of minerals, river valley projects, right? So, however, this is the overall terms of reference for uh, giving the EIA report, right? If you look at these, it sort of gives you for each uh, sector, it gives you what kind of terms of reference. Let's randomly take a look, right? So that's the Okay, so this is for a coal mining project, right? Standard TOR for an open cast coal mining project. So they actually give what all needs to be filled, right? So this is the hectares, this is the capacity, right? What all do you need to attach in your assessment? You need to give a study area, map specifying locations of the state district project location, land use map at what scale is also, mentioned. Like you'll have to comply to these things when you're submitting your environmental impact assessment, right? There is a contour map, a detailed site plan, and then there are certain like tables that you need to give specific details about, like how much agricultural land is there, forest land is being occupied, all of these. So this is sort of to give you an idea, right? So यहाँ पे you can see detailed water balance should be provided. So this is where your water balance equations and all come in, right? So this is a sample of what a TOR looks like. So you can see, like, cumulative plantation. What are they planning to do as a mitigation, right? So the next file that so this is the list of standard TOR as per EIA, and this is the overall project one. So they also have guidance manuals for each sector, right? So for example, EIA guidance manuals, mining of minerals, offshore, onshore, thermal power plants, nuclear power plants. So all of these sectors have coal washeries. They have their separate guidelines that are given. So this is a manual for the sugar industry, for example. You can see how they've elaborated on the conceptual facets, yes, about the sugar industry, some basic aspects. Then we look at the operational aspects of EAA. So how do you do the screening, scoping? Then how do you do the assessment? So within that, social impact assessment, risk assessment, mitigation measures. What are the measures that you'll have to consider for a sugar industry? How do you report? How should public consultation be? Right? So this is sort of a guideline document. Okay. So then we also have, so apart from this, let's take a look at an example, like an example EIA report, right? It's a very rudimentary report. It's not as detailed, right? So this is for a road development project. So after the introduction and all, they sort of describe the project as to what is going to be done, right? Then the policy and legal and institutional framework as to under what law they're actually going ahead with the project and what are the implications of the laws. Then they do the baseline environmental status. If you remember, we sort of need to do this, right? So what is the current status in the site? Like you can see geological analysis of the area, seismology, soil characteristics, landslides, climate, rainfall, physical environment, ecological resources, socio-cultural environment. So it's like a detailed description of what the current status is. Then public consultation. How has public consultation been conducted throughout the project planning stage? Then we have analysis of alternatives. They have a few alternatives that could have been done. Again, something that is essential in an EIA. Then this is the impact assessment, right? What is the impact on physical environment, like soil, water resources, air, environment, noise? Then so impact on the roadside trees. This is majorly highlighted because it's a very significant aspect of this project, right? Then socio-cultural environment, what is the impact? What is the impact on safety and public health? Then they sort of outline, like, avoidance, mitigation, and enhancement measures. So how are they going to avoid certain things? How are they going to mitigate some of the bad effects of the project or enhance some of the good effects of the project, right? So that is on physical environment, natural environment, social cultural environment, etc. So this is just to give a very basic idea as to how it is done, right? So you can see this is the project description. They've given detailed drawings of the project. So this is all the analysis. You can see how they've given the levels. This is the standards, right? Then they've given how have they arrived at the um, air quality monitoring locations. So these are the three locations of the air quality monitoring stations. Then how have they done this actually, right? All of these needs to be given. These are the details of the monitoring. So this is the baseline description, right? Then you can take a look at this project just to, like, for example, here they've sort of given the socioeconomic profile of the area, right? Then how has public consultation been done? What all did they do? So pictures of, the actual public consultation happening. So this is how the report looks. I'm not saying it's like, I'm not assessing the report on its quality, but it's just to illustrate as to, how a report is. So, yeah. So with that, we come to the end of our session. I know I sort of rushed through the current assignment problems, but I hope uh, there are a couple of clarifications that need to be given with a few questions. Those will be addressed shortly. So I will post in the discussion forum, and I'll get in touch with the team, post in the discussion forum, and I'll also, when the YouTube video is uploaded, please check the descriptions for the clarifications wherever we got stuck. Right? Are there any other queries? If not, we'll close the session for the day. Uh, I hope to see you soon in the next week's live session. Okay. Thank you for being a part of today's class. There was very less attendance, but I hope more of you sort of take a look at the YouTube video, and I hope it was helpful. Thank you.